Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju Institute of Technology, Narsapur. In this linear algebra and calculus course, we are going to learn about another example on Jacobian concept. Let us see problem statement. If x is equal to r sin theta cos pi and y is equal to r sin theta sin pi and z is equal to r cos theta, then we have to find the Jacobian from x comma y comma z to r comma theta comma pi and its reciprocal dou of r comma theta comma pi with respect to x comma y comma z. So, we are going to find the solution of this problem by computing the partial derivatives of the dependent variables with respect to all possible independent variables. So, everyone should note here that x comma y comma z are dependent variables, r comma theta comma pi are independent variables. So, first we have to compute partial derivatives. So, dou x by dou r. Sin theta and cos pi will be treated as constant. R derivative with respect to r is 1. And similarly, we have to compute dou x by dou theta. R is treated as constant, cos pi is also treated as constant, and sin theta derivative is cos theta. Similarly, dou x by dou pi, r is constant, sin theta is also constant, and cos pi derivative is minus sin pi. After that, we have to compute y derivatives, dou y by dou r. This is sin theta constant, sin pi constant, and r derivative with respect to r is 1. And dou y by dou theta, r constant, sin pi constant, and sin theta derivative with respect to theta is cos theta. Similarly, dou y by dou phi, r constant, sin theta constant, sin pi derivative is cos pi. And finally, z, partial derivative of z with respect to r, dou z by dou r. Cos theta is constant, r derivative with respect to r is 1, and dou z by dou theta, r is constant, cos theta derivative is minus sin theta, and finally dou z by dou phi, r and cos theta are independent of phi, therefore treated as constant, constant derivative is 0. Now, all these we have to substitute into the definition of Jacobian. Jacobian is x comma y comma z by r comma theta comma pi. We are going to get x r, x theta, x phi, y r, y theta, y phi, z r, z theta, z phi. Let us substitute the values. Sin theta, cos phi, and x theta is r cos phi, cos theta, and x phi is r sin theta minus sin phi, and the second row is yr is sin theta and sin phi, next r sin phi, cos theta, and finally r sin theta, cos phi. Last row is cos theta minus r sin theta 0. So, we can compute the Jacobian with respect to any row or column. Let me take for simplicity with respect to third row, and we can give the signs plus, minus, plus, and this is minus and this is plus. So, we have to compute the determinant. It is equal to cos theta multiplied with corresponding column and row will be neglected, and remaining submatrix determinant here r cos theta cos pi and r sin theta cos pi When you multiply these two, we are going to get r square cos square pi followed by sin theta cos theta minus into minus plus here r sin theta sin pi, r sin pi cos theta. Sin pi repeated and r is also repeated. It will be r square sin square pi sin theta cos theta. This is first term. Similarly, minus into minus plus second term, corresponding third row and second column will be neglected, and the remaining we have sin theta cos pi multiplied with r into sin theta cos pi. So, r sin theta multiplied with sin theta cos pi, r sin square theta cos square pi, and minus into minus plus r sin theta sin pi multiplied with sin theta sin pi, r sin square theta sin square pi. This we have to simplify. So, from this bracket term, first bracket term, we can take r square sin theta cos theta common. It is equal to cos theta into r square sin theta cos theta common. It remains cos square pi and sin square pi. Cos square pi plus sin square pi, this is forced to 1, and then plus r sin theta times. In this also we can take r sin square theta common. R sin square theta common, it remains cos square pi and sin square pi. This is also forced to 1. So, cos theta multiplied with cos theta will be cos square theta and sin theta, and it will remain r square also in the first term. And coming to the second term, r into r square sin theta and sin square theta will be sin cube theta. So, from this if you take r square sin theta, it will remain cos square theta plus sin square theta. Again this will be forced to 1, and this is given by r square sin theta. Okay. So, this is how we are supposed to compute the Jacobian of x comma y comma z with respect to r comma theta comma phi is given by r square sin theta. Again they are asking the reciprocal of this. So, by using the property of Jacobian, we know that j into j dash is equal to 1. This implies j dash is given by Jacobian of r comma theta comma phi with respect to x comma y comma z is given by 1 by j. This is 1 by r square sin theta. So, therefore, j dash is equal to 1 by r square sin theta. This is how you are supposed to compute the Jacobian of 3 dependent variables which are expressed in terms of 3 independent variables. Thank you for watching. Next class we will see another example on Jacobian. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.